For the first time in human history, we know the exact half-second the moon gets hit. And this time, the whole world can watch. Next week, a derelict rocket the size of a 5-story building strikes the lunar surface with the energy of 3 tons of TNT. The only other predicted impact hit the far side, hidden from every telescope on Earth. This one hits the visible edge, where 800,000 pounds of moon dust could rise into black sky. Here's when it happens, why nothing can stop it, and how to watch it from your backyard. 6 days from today, at 34 minutes and 32.9 seconds past 6 in the morning Universal Time, on August 5th, a 5-story piece of rocket hardware slams into the moon at 5,400 miles per hour. That is not a forecast with error bars measured in days. The formal solution is good to about half a second in time and about 300 meters in position. The astronomer behind the calculation trusts it conservatively to a few seconds and a few kilometers. Either way, this is one of the most precise appointments in the history of spaceflight, and the appointment cannot be moved. Think about what that precision actually means. Weather forecasters can't tell you within half a day when a hurricane makes landfall. Earthquake scientists can't give you a date at all. But for this event, a collision between a tumbling dead rocket and the moon, astronomers have published a time stamped to the 10th of a second 11 months in advance. The prediction has been public since last September. Humanity has been watching this one coming for almost a year, refining the appointment with every new observation, and the appointment has held. For viewers in North America, the timing translates to 2:34 in the morning Eastern on Wednesday, August 5th, which is 11:34 Tuesday night on the West Coast. The target is the moon's near side, at 19.4554 degrees north latitude, 93.594 degrees west longitude, near a crater named Einstein, in old, heavily cratered terrain almost exactly on the moon's western edge as we see it from Earth. That location matters more than any other detail in this story, and here's why. The last time a piece of human-made junk was predicted to hit the moon, it struck the far side, completely out of view. This one hits where telescopes can actually point. No one alive, no one in history, has ever watched a predicted human-made object strike the moon. Next week is the first scheduled chance anyone has ever had. And the strangest part of the story isn't the collision itself. It's that the entire apparatus of human spaceflight, every agency, every tracking network, every mission control room on Earth can do nothing about it except watch. To understand why, you need to know what this object is and how it spent the last 18 months. The object carries the catalog designation 2025010D. It's the second stage of a SpaceX Falcon 9 that launched on January 15, 2025, carrying 2 commercial moonlanders at once. One of them, Firefly Aerospace's Blue Ghost, touched down successfully on March 2, 2025, the first fully successful commercial lunar landing ever. The other, ISpace's Resilience lander, went silent about 90 seconds before touchdown that June and crashed. The rocket stage that threw both of them toward the moon had no such destination. Its job done, it was left in an enormous lopsided orbit around Earth, swinging out as far as 510,000 kilometers, back into about 220,000, looping around once every 26 days. Here's the problem with that orbit. The moon circles Earth at about 385,000 kilometers. The rocket's path crosses that distance twice on every lap. For 18 months, the stage and the moon kept missing each other. Close pass after close pass, nothing more. And this is worth pausing on. The collision was never inevitable. Multiple near misses came and went, and each one slightly reshaped the orbit. What finally locked the rocket onto the moon wasn't a malfunction or a maneuver. It was sunlight. The same faint push that complicates the tracking, slowly hurrying a dead machine toward a world it was never meant to touch. On August 5th, for the first time, the stage and the moon arrive at the crossing point at the same moment. The other 2 objects from that same launch met tidier ends, which sharpens the contrast. The payload canister that held the landers together fell back and burned up over the southern tip of South America in March 2025. The landers reached the moon on purpose. Only the rocket that delivered them was left with no plan at all, parked in an orbit nobody managed, on a path nobody owned. The stage itself is about 12 meters long and 4 meters wide, the height of a 5-story building. And it's mostly hollow, empty aluminum lithium fuel tankage with a single Merlin vacuum engine bolted to one end. Its mass is somewhere between roughly 3,900 and 4,900 kilograms, depending on which research team's estimate you use. It has no fuel, no power, no working thruster, and no radio. It's been dead hardware since January 2025, and every meter of its path since then has been set by exactly two forces: gravity and sunlight. Now ask yourself, who discovered this collision was coming? It wasn't NASA. It wasn't the Space Force. It wasn't any government tracking network anywhere on Earth. It was one contract astronomer named Bill Gray, who runs a project called Project Pluto, whose orbit computation software flagged the impact back in September of 2025 while chewing through observations collected almost by accident. That deserves a moment, because it exposes something most people don't know. Military radar catalogs, low-orbit debris down to lost astronaut gloves, and dropped tool bags. But radar obeys a brutal rule called the inverse fourth power law. Push an object 400 times farther away, and its radar echo comes back roughly 25.6 billion times fainter. At lunar distances, the world's radar fences are effectively blind. The only instruments that see high-flying junk are asteroid surveys, telescopes hunting dangerous space rocks that occasionally catch a slow-moving point of light that turns out to be a discarded rocket, and a scattered community of amateur astronomers. Sit with that for a second. The asteroid surveys that flagged this rocket weren't looking for it. To them, high-flying junk is a nuisance, false positives contaminating a search for objects that could actually kill people. The discovery of a moon impact 16 months in advance was, in effect, a byproduct of someone else's telescope time, noticed by one man running orbit software that no agency commissioned. That patchwork community is what tracked this object. By late February of this year, 1,530 observations had piled up from observatories in Mississippi, Utah, Beijing, and England, plus surveys and backyard telescopes. One British observer captured a 12-minute exposure in which the tumbling stage brightened and faded 5 times. Another measured its light curve at a little over 3 minutes per cycle. Those tumble measurements aren't trivia. They're the whole ballgame for the prediction, because the one force nobody can compute perfectly is sunlight. Solar radiation pressure, the faint, constant push of light itself, keeps nudging the stage, and how hard it pushes depends on how the object tumbles. Gravity is known to extreme precision. The sunlight push is why the June update moved the predicted impact point 170 kilometers northwest, and why the July 17th update moved it only a couple of seconds and about 10 kilometers. The prediction is converging. The rock-solid appointment stands. So why can't anyone stop it? Not because of physics, because of absence. There's no engine burn coming because the stage has no fuel. There's no command to send because it has no radio. And there's no rescue mission being scrambled because no such mission exists anywhere on this planet. No agency, no treaty, no office in any government has the assignment of managing dead rockets in the space between Earth and the Moon. Gray himself put it bluntly, generally speaking, high-altitude junk goes ignored. Except it appears by him. Let that stand as a plain fact, because it's the honest center of the story. A civilization that can predict a collision 16 months in advance, to the half-second, on a body it's actively planning to inhabit, has no one whose job it is to know about such collisions, let alone prevent them. Nothing about August 5th can be stopped, and nothing is trying. What can happen is science, and as it turns out, quite a lot of it. Start with the raw numbers of the impact itself. At 2.43 kilometers/s, carrying up to 4,900 kilograms, the stage hits with about 14.5 billion joules of kinetic energy. That's the energy of roughly 3 tons of TNT, about 15,000 sticks of dynamite delivered to one point on the lunar surface in a fraction of a second. The stage will be moving at what would be Mach 7 in air, arriving at an angle of about 31 degrees above the local horizon. The expected result is a brand new crater somewhere between 17 and 30 meters across. The lower estimate is scaled from the last junk impact in 2022. The higher one comes from the team organizing next week's observing campaign. Both estimates agree the crater will be smaller than an asteroid of equal energy would dig because the stage is a hollow shell, not a solid slug. The excavation, though, is real, on the order of 450 cubic meters of lunar rock and soil, roughly 1,100 tons, about 800,000 pounds of the moon, blasted outward with no atmosphere to slow a single grain of it. And this is where the impact turns from accident into asset. Every crater scientists have ever studied came from an impactor whose mass, speed, and angle had to be guessed after the fact. Next week's crater is different. The projectile's size, mass range, velocity, arrival angle, and arrival time are all known in advance, down to the half second. That makes the fresh scar near Einstein crater a calibration point for the crater scaling laws scientists use everywhere, including the models behind planetary defense. The calculations that would tell us what a dangerous asteroid would actually do to a city. A dead rocket is about to hand that field a free ground truth experiment. 800,000 pounds of debris rising off the moon on a schedule humanity wrote for itself 11 months in advance. The question that decides whether next week becomes a global spectacle or a quiet footnote is brutally simple. Will anyone actually see it happen? And the answer splits into two very different pieces, a flash and a cloud. Here's the disappointing half. First, the impact flash itself. The split-second burst of light at the moment of contact will almost certainly be invisible from Earth. The impact site is in full lunar daylight, and no impact flash has ever been convincingly detected against the moon's sunlit surface, not even by professional observatories. Worse, this impactor is slow by lunar standards. Natural meteoroids hit the moon at 10 kilometers/s and up, some past 70, and the fraction of impact energy that becomes visible light climbs steeply with speed. At 2.43 kilometers/s, this stage produces a bottom-of-the-scale glow buried in daylight. The physics of that is simple and unforgiving. An impact flash is thermal light, vaporized rock and metal glowing for a fraction of a second. The hotter the impact, the brighter and bluer the glow, and impact heating scales with the square of velocity. A meteoroid at 20 kilometers/s delivers nearly 70 times the energy per kilogram that this stage will. Astronomers routinely record those natural flashes, but only on the moon's night side, against darkness. This impact stacks the deck the wrong way twice, a slow projectile on a sunlit surface. If that sounds pessimistic, history agrees. In October 2009, NASA ran this exact experiment on purpose. The LCROSS mission steered a spent Centaur upper stage into the crater Cabeus, timed the strike for lunar darkness, and pointed large telescopes at the site. From Earth, they saw nothing. If a deliberate impact staged for ideal viewing conditions produced no visible flash, a dead rocket hitting a daylit surface won't beat it. But the flash was never the real prize. The real prize is what comes up afterward. 2 research papers published this month define the actual opportunity, and this is where next week gets exciting. Because the impact point sits almost exactly on the moon's western limb, the visible edge. Any dust thrown upward could appear from Earth, silhouetted against black sky, hugging the bright rim of the moon, lit by sunlight scattering through the grains. Not a flash on the surface, a cloud rising off the edge of another world. The modeling team ran the numbers on that cloud. Their simulation shows an ejecta curtain climbing 15 to 20 kilometers above the surface, with a central spike of fast debris reaching 75 to 100 kilometers high, and material spreading about 183 kilometers outward from the impact point. Above 10 kilometers altitude, the peak dust column density comes in at just over 60 million particles per square meter. In the first few minutes, the simulated cloud outshines the dark sky background by several orders of magnitude. The plume could linger, by their model, on the order of 10 minutes. That's the optimistic case. The honest case is a genuine open question, and the man who predicted the impact is the source of the caution. Gray's own back-of-envelope calculation assumes slower ejecta, around 100 meters per second, which rises only about 3 kilometers before falling back, separating from the moon's bright edge by a mere 1.5 arcseconds, marginal for any telescope on Earth. The wild card is speed. If a meaningful fraction of the debris leaves at 300 meters per second, it climbs for 3 minutes and reaches 9 times higher, and the event becomes unmistakable. The modelers say, watch. The predictor says maybe. Nobody on Earth knows. And that's precisely what makes next Wednesday morning an experiment 11 months in the making, with the whole planet invited to run it. There's even a chemical twist. The stage's tanks are an aluminum-lithium alloy, and observers are being encouraged to try a narrow filter tuned to the lithium emission line at 670.8 nanometers. If that faint lithium glow shows up in the plume, it would be a first in history. The chemical fingerprint of a human-made impactor read directly from its own debris cloud, and a proof of concept for reading the composition of any impactor from the light of its ejecta. To understand what to expect next week, you have to go back to the only precedent, March 4th, 2022, because that event calibrates everything about this one, and it left behind a mystery that August 5th might reopen. That was the first predicted lunar junk impact in history, called by the same one man, Bill Gray, not by any agency. And it began with an embarrassment. The object was initially identified as a Falcon 9 stage from a 2015 launch, then re-identified after independent observers matched its paint spectrum to Chinese rocket hardware as the upper stage from China's Chang'e 5T1 mission of 2014. China denied it. Beijing has never acknowledged the impact to this day. That stage hit the moon's far side near a crater called Hertzsprung, where no telescope on Earth could watch, which is exactly why next week is unprecedented. When NASA's Lunar Reconnaissance Orbiter found the site 3 months later, it photographed something nobody predicted, a double crater. 2 overlapping pits, 16 and 18 meters across, spanning about 30 meters. A double crater implies significant mass at both ends of the impacting object, mass that was never disclosed on any manifest. That anomaly has never been explained. A double crater means the object that hit was heavy at both ends. But a standard rocket stage is a hollow tube with one heavy engine. Whatever else was mounted on that Chinese stage, no public document accounts for it. It remains one of the strangest unsolved details in the modern lunar record. A piece of hardware that left a signature its own manifest can't explain. Here's why that matters for August 5th. The Falcon 9 stage arriving next week carried its heavy engine at one end and nothing comparable at the other, so the prediction is a single crater, roughly 17 meters across. When the Lunar Reconnaissance Orbiter photographs the fresh scar near Einstein crater in the weeks after impact, that image becomes a verdict. 1 crater, the physics closes cleanly. 2 craters, and the 2022 mystery reopens on an object we thought we understood completely, this time with 1,000 observations of tracking record behind it. And for anyone worried about the moon itself, it takes hits like this constantly. In the spring of 2024, a natural meteoroid gouged a 225-meter crater into the lunar surface, 10 times the diameter and roughly 1,000 times the energy of next week's impact. And no one on Earth noticed it happen in real time. Apollo mission planners deliberately crashed the upper stages of Apollo 13 through 17 into the moon as seismic experiments, and the seismometers recorded the moon ringing like a bell. The moon will be fine. What's new next week isn't the wound. It's that this one is ours. We saw it coming. And for the first time, we get to watch. So the collision is harmless and scientifically useful, which brings back the question this story keeps circling. If we could see it coming for 11 months, why does the answer to who's handling this keep coming up empty? The reason August 5th can't be stopped is not engineering. It's that between Earth orbit and the moon lies a volume of space where surveillance is effectively blind, ownership is undefined, and cleanup is nobody's job. Roughly a dozen dead, high-flying objects are currently known to be wandering that region, known only because one contractor in a community of amateurs bothered to keep looking. More than 600 Falcon 9 rockets have launched. Most spent stages fall back into Earth's atmosphere or are thrown into orbit around the Sun. This one simply wasn't. And once it wasn't, it belonged to no tracking system on Earth. Compare that to how seriously we take the space closer to home. Low Earth orbit has collision avoidance systems, conjunction warnings, debris catalogs updated daily, and international pressure on operators who leave junk behind. Cross an invisible altitude line, and all of it evaporates. The stage that hits the moon next week spent 18 months in a region where the sum total of humanity's monitoring effort was one contractor's software and whatever asteroid hunters happened to catch by accident. If it had been on a path to hit something that mattered to us sooner, a lunar orbiter, a lander on final approach, the warning would have come from the same place, one man's inbox. What makes that uncomfortable is that the fix exists and costs almost nothing. It's called heliocentric disposal. Use the last breath of fuel to throw the spent stage into orbit around the Sun, permanently out of Earth-Moon space. It was done for the stage that launched the James Webb Space Telescope. It was done as recently as November for the Falcon 9 stage from the Escapade lunar mission. It's simply not required, and so it's not routine. Meanwhile, the traffic is multiplying. The Artemis era means more lunar launches, more discarded stages, more dead hardware crossing the paths of future landers, orbiters, and eventually crews. Every one of them will fly through the same untracked volume this rocket has wandered for 18 months. Next week's impact is a free warning shot, the gentlest possible demonstration of a blind spot that won't stay harmless forever. Before wrapping up, let's deal with the claims spreading online that this impact is deliberate, that the stage is being aimed at the moon, or that its identity is being hidden. The tracking data dismantles both in seconds. The stage has been unpowered for 18 months. Steering requires propellant and a working engine it doesn't have. The predicted impact point drifted 170 kilometers between two updates this summer, pushed by nothing but sunlight. Nothing aimed behaves that way. As for identity, the 2022 mix-up gets cited as precedent, but it proves the opposite. That misidentification was caught and corrected in public by independent observers using the object's own paint spectrum. This object is anchored to its January 2025 launch by more than 1,000 observations. The record is open. The physics is boring. The truth is stranger than the conspiracy. Nobody aimed this rocket at the moon, and nobody was capable of aiming it anywhere else. So here's what happens next, and how to see it for yourself. Between now and August 5th, tracking updates will pin the impact down to within a few dozen meters and a fraction of a second. Watch for the final solutions in the first days of August. There's one genuine wildcard left, a small chance the refined impact point slides slightly. And because the site sits right on the visible edge of the moon, a shift in the wrong direction could push it over the limb to the far side, hiding the entire event. Every update between now and next Wednesday matters. If it stays on our side of the line, the viewing geometry favors this audience specifically. The eastern half of North America and much of South America get the best seats. The moon will be up about 56% illuminated in a dark sky at impact time, rising around midnight to 1 o'clock in the morning local time in the eastern United States, with Saturn conveniently nearby as a signpost. The observing campaign's advice: you don't need an observatory. Backyard-class telescopes may be enough. Frame your shot so the moon's bright disk sits just off the edge of the camera sensor. Kill the glare and record at 20 frames per second or faster. An infrared filter helps cut the daylit disk's brightness. And if you want to attempt the historic measurement, that lithium line at 670.8 nanometers is the target. Run a dry rehearsal the night of August 4th, when the moon sits at nearly the same phase and position. There's also a quieter experiment riding on this. The observing campaign is explicitly using August 5th to test a pipeline for pinpointing lunar impacts, a direct descendant of the Apollo era when those deliberately crashed rocket stages calibrated the seismometers astronauts had left on the surface. If the localization works on a known impact, it becomes a tool for future lunar seismic networks watching for unknown ones. Success or failure, the data flows somewhere useful. Then, in the weeks after, watch for the Lunar Reconnaissance Orbiter's photograph of the fresh crater near Einstein. The image that either closes the file with one clean scar or blows the 2022 double crater mystery wide open again. and know that both outcomes on the night itself carry a follow-up. If the plume rises and cameras catch it, those images will circulate within hours, and this channel will break them down. If the moon swallows the moment in silence, that silence is itself the answer to a question scientists have been arguing about all month. And it tells us something sobering about how much can happen in nearby space without anyone seeing it. Either way, next Wednesday morning, humanity keeps an appointment it made by accident and confirmed to the half-second. The first moon impact in history that anyone alive has ever been able to watch happen. Whether the dust rises high enough to see, or the moon swallows the moment in silence, the answer arrives at 34 minutes past 6, universal time. We'll be tracking the final orbit updates, the impact window, and the first images as they come in. Watch the limb.